What's up, Evan? Evan, are you there? Wow. Oh, what? Hello. Oh, shoot. Evan!
Oh yeah, sorry, my headphones were on.
That's okay, no problem.
What's going on, man?
Oh man, it was a very eventful day today.
Yeah? How
Yep.
did you interview? Like over
No,
Skype or something?
yes. Obviously it was over the phone. But I don't know how the heck, I don't know, like, what was in May, end of May, this recruiter contacted me saying, hey, I have an opportunity for you on Facebook. I'm like, sure.
Wow.
So I was like, okay. At first I was like, this guy's probably joking, right? So I was like reading through, and it was actually a Facebook thing. I was like, fucking yay, well, I'm gonna go there, right? But it wasn't a technical role. It was like a support role for a product called CrawlTangle that is launching in Latin America. So they needed someone that understand the business. Oh, actually, where's my video? I'm sorry, guys. Hey, Edwin, I'm sorry, I didn't see you there.
Yeah, can you hear an echo? I'm just trying to test out my mic.
Echo?
No, I don't hear an echo.
No, me neither. Where's Matt? Matt.
It's taking today off.
Are you serious? No, he can't take off.
No, I don't. I'm just
Oh,
kidding.
okay. So, actually, let him let him join us. So I share this story with you guys.
Are you kidding me? Okay, fine.
Mhm. I swear to God.
Just finish the story.
I got an interview at Facebook today.
How was it?
It was fun. Oh my God, it was actually super because it was the first time that I was talking to someone that it wasn't actually technical, but I thought he was a little technical because he had this I don't know, operation and like a procurement background, but and it was like a support role. So I was expecting him oh, tell me about your experience at Bloomberg, for example. How did you make sure all the clients were taken care of, operational? How'd you guys work on your shifts? What do you guys, something like that, right? Oh, Matt is here. Hello?
Hello. Nice.
Oh man, I was telling them my eventful day of having an interview at Facebook. So, oh my God, it was so funny.
Well or no?
I don't. Well, dude, if that guy called me to work there, I don't know, it's probably going to be desperate because I was he was asking me questions about. So if you don't know an answer to a customer, how would you go about to resolve that problem? I was gonna ask him the question until I know the answer, and then look at the documentation, and then give the answer, or I would just do a Google full or a Google. And he was puzzled, So he's like, oh, tell me an experience that you are trying to figure it out, a bug in your, I don't know, whatever. It's oh, let's say you were analyzing the data and then something went wrong, and then you notice, so how would you go about to solve that problem? I was I was gonna first look at the error, and then I was gonna debug it, whatever, there's a thing called Stack Flow. And then I was just gonna Google, and so I don't know.
You're killing me. Come on.
No, swear to God,
You're giving away all our secrets.
What?
You're giving away all our secrets. Just Google it.
Oh,
Exactly.
I mean, I don't know. I shouldn't have said that.
Nah, man, that's fine.
I mean, you gotta
Part of the
Google.
process. I guess I don't really get. What were they trying to ask you? What kind of problem?
That's the thing. There was no problem. He was just giving me a very random question, no, but I gotta start from the beginning. I should fucking record it. Oh my God! First of all, he He was supposed to call me at 1:30.
Cancel the recording for now.
So this apparently went really well.
Which, I mean, what I'm gonna do? I'm gonna be miserable saying that. Oh, I got rejected at Facebook, and I'm like, come on, huh? No, so he was supposed to call me at 1:30, and I was like 2 o'clock. I was like, guy's not gonna call me. And then a recruiter sent me an email, right? She's like, they want you to be initiative, and she put like in caps, initiative. So you gotta have a lot of initiative on your end. I was like, initiative, what do they mean by that? So I started Googling initiative, what initiative means, right? And they're like, oh, you wanna take? I was like, okay, cool. So you know what? I'm gonna take initiative, and I am going to frigging find, because I think he's waiting for me to see what I was gonna do in a situation like that, right? So I Google him, I find him on Facebook, I find him like on LinkedIn, and I was like about to like call him on Facebook. and the recruiter like, she's like, no, don't call him. I was like, wow, you asked me to be initiative, like, you know. She's like, no, we have an agreement, we can tell them like that you're gonna call him. Oh my god. So I don't know. So he asked me everything but about support. If I speak Portuguese, which was a must, right? If what else? Spanish was a plus. If I knew data, it would be like another plus. So I don't know. It
Do you
was
know Spanish?
Huh?
Do you know Spanish?
Yes, I know Spanish. Come on, Evan.
Oh, I
Evan.
just do Portuguese. I'm sorry.
No, you said gordo. I said gordo. Oh my god. I'm sorry, guys. I'm a little. I think I'm a little jaded. What's my jaded or something?
Flustered.
Yeah, like.
Or like hyped or.
No, it's just like a weird. We're like living in a very weird times, man. Like it's like everyone like fighting, like, you know, people like, oh, it's just like I don't get it. Like they all should come here and learn how to code. That's what I should, you know. Anyhow. Hey man, I'm sorry. I was probably more venting out than anything else.
That's how I want it.
Yeah,
I love it.
really great, man.
If anyone wants to start a discussion based on that, that'd be great.
Yeah, like
next
a
time
weird
we
interviews.
need to record it.
Yeah. Oh, actually, where's Lee? Lee. Wait, Lee's here.
I don't think it's in here.
Man, what's going on with Lee? Oh, you. Wait, you Lee. How you doing? You Lee. Oh, it's you. I'm sorry. How are you? How are you?
Yeah, good.
Awesome. Hey guys, she made our logo actually.
Oh, wow.
Yep.
Well, thank you. It looks really nice.
Come on, you sell your fish.
Matt gave me the chance to do that.
I'm sorry?
Matt gave me the chance to do that. So, and also Tom, you
You
introduced.
did an
So.
incredible job. We very much appreciate it.
Andre,
Awesome.
where's Herman? My he's gonna teach me how to work on DevOps.
Nice. Oh, yeah? Nice.
No, like come on. He's a busy guy. He's gonna teach me like DevOps.
He'll definitely give you at least one lesson if you ask him.
No. He actually gave me a list of type of technology that I should know in order to become a good DevOps.
Number one, shell scripting.
I'm sorry?
I said number one, shell scripting.
You cut it out. I'm sorry, Andre.
I'm cutting out?
Just at the end. Oh, maybe it's my ear.
No, it's not your ear. It's probably the Discord auto capture. But
He's
I said
talking about shell
the
scripting, like Bash.
I said shell
like,
scripting.
LS or C.
Oh, shell scripting.
Like,
Yeah.
Oh.
Yeah, learning the shell scripting language is pretty critical.
Oh, I love shell scripting. Actually, a funny story. That was, well, Matt, when you came to class, it was like almost at the end of the semester, right?
Yeah, that's
What?
when Matt joined up.
Yeah. So like we like all like listening to Lee to preach his like machine learning thing, and Edwin is always pissed. Like, you know, you guys have to fucking read documentation. And I see this guy coming in with a leather jacket and like a Indiana Jones. Where's Matt? Oh man,
What, like a satchel?
huh?
Like a satchel? Like an Indiana
Yes,
Jones
yes, yes, yes. This guy was like, "Who's this guy?" So he sits like in the middle of the class like this, and he's like, and then I was trying to open Anaconda, and my Anaconda was not open. I was like, "What the heck? Like Anaconda, you worked the whole semester, and that's gonna fail me right now."
Oh man.
And then Matt's like, "You need help?" I was like, "Yes." So Matt like, and then he starts scripting shell. Like I was like, "Oh fuck, man, I love doing Bash, man. I love shell." He's like, "Oh, you do? You should become a DevOps." I'm like, "DevOps? No, I'm gonna become a data scientist with DevOps." And then the other weeks, like DevOps thing is actually something that I want to learn, not data science. I'm sorry, Evan and Edwin. Hello?
What?
Nice. All right.
Well, thank God
I
it's...
think that was a fantastic.
yeah, go. Sorry, guys.
From now on, I think Tom should do 10 minutes of ranting at the beginning of class.
Oh, okay, last one. Thank you, Mark Zuckerberg, for the experience. I love it.
Shout out.
Oh, hi, Mark.
Oh, we maybe get some likes.
Yes. All right. So today's class is going to be starting off with Edwin doing some. Edwin, you're working on. I'm blanking right now. Video game rendering stuff, right?
Real
rendering
Engine.
a little bit, but mostly just gameplay mechanics and an overview of the Unreal Engine and 3D.
All right, and then Evan afterwards is going to come in and talk a little bit about a serverless framework that he's been working on with, right, Evan?
Yeah, we're just going to do like a simple Hello World application using a tool called Zappa that's written in Python.
Cool.
Serverless.
Beam code?
No, we're not doing
Wait.
code this time.
No. Why would my intermediate skills improve?
No, because the labor department came and they knock on the door and say, "Hey, you guys need to pay extra for Edwin to do the leak code."
I'll
Like,
never get into Google like this.
He's an influencer on YouTube now, so he
Exactly.
he's, we're getting there. Yeah. Just a little bit that I want to say. So we had like a conversation at the end of last week that was kind of talking about like what is this group and like that conversation. I thought it was it's definitely been on my mind a lot the past week, and I have a lot of thoughts that I'm not going to share today because I still want to reach out to everyone individually and kind of bounce ideas off of them to make sure that everyone is kind of incorporated into it. But I do want to acknowledge that it's like an important thing to kind of have a specific reason, have a specific direction, and that's I think something a lot of people have been asking for, and so like they can come in here with a little bit more expectations about what to expect and what's going to be happening. But for now, we're just going to continue this kind of like informal. People sign up for lectures, and then we'll kind of we're brainstorming a plan of how that's going to go forward.
Thank you, Matt.
So without further ado, Edwin, do you mind taking over?
I think Andrew wanted to say something.
Yeah.
Andre, did you want to say something? Sorry.
Not that I can remember.
Oh, I'm sorry.
Oh, okay.
I love that.
That was very exciting today. That's good.
I know.
We got some enthusiasm.
Oh God.
All right.
Yeah. So Tom, a few friend of mine want to watch the recording. So if the recording is going on, let me know if the voice feedback is good because I'm using this mic. And I don't know
No,
if
it's actually loud and clear. I think it's perfect.
Okay.
Yep.
Yeah, because I'm not using headphones, I'm using speakers. Okay, so, all right, let me share my screen. So, I'm going to give an overview in lieu of leak code of the Unreal Engine. And let me see if I can actually share my full screen and not just...
Oh, that's cool.
I believe this should be... All right, so yeah, I hope it's not just streaming the app, but my whole desktop. But if it is a streamed app, we can always restart. All right, so yeah, so the Unreal Engine is a very powerful interface that is really geared toward 3D games. And I think it would be remiss not to show some demo of actual games. So I'm going to show both a shooter game that you can download from the Epic Games Launcher and actually see the code and see how games are developed in terms of rudimentary gameplay. So while this is loading,
Edwin, I'm so sorry to interrupt you, but I think your stream kind of cut it out or something. I don't see it
It
anymore.
went dark.
yeah. So I think it's. Yeah. Instead of showing the application, I'm just going to show my whole screen. Does this work for everybody? Yeah.
Yep.
Okay. So yeah. So because you guys couldn't see it, so before we do anything else, please. If you have the graphics card and your computer has enough space, you should, if you want to play along and launch the Unreal Engine, the first step is to download the Epic Games Launcher. So Epic Games is the one that makes and maintains the Unreal Engine. And they have a really cool launcher that, as Evan and I know, they also offer free games every other week. So you can pick up Civilization and other cool games that they've offered. So that just spazzed out on me. All right, so yeah, so you can launch the Unreal Engine from this Epic Games Launcher, and you can see that there's news going on. You can also download Marketplace assets by clicking on Marketplace, and you can see that there's a lot of paid in terms of art assets, music assets. So I've used up a lot in this particular tutorial using what's known as Infinity Blade, which is a game that Epic Games has made. And they have a lot of good assets, but they've also offered them for free. And you can also download some really cool, what are known as paragons, or some really cool characters. So for example, let's see like this character. And you can see that there's a lot of time that's been spent on developing these characters. So it's really cool just in terms of giving a brief tutorial of just using these paragons instead of just following a simple robot around all the time. So that's the Marketplace. And then here's a really interesting part. If you go to the library, you'll be able to actually see the demonstrations that I've made, and also you can download Epic Games sample projects. So they have shooter games, vehicle games, and action RPGs. So let's actually just see how it goes, how one of these sample games goes. So this is their first-person shooter game, and let's actually launch it right from the Unreal Engine. And I think this will give you a great idea of how the Unreal Engine works. So I'm going to open up this in a separate window. You can see a very cool, but you can see the match beginning in 13 seconds. And you can see like, this is how most first-person shooter games go in terms of really beautiful interfaces, 3D graphics, collisions, guns, shooting.
Oh, that's cool.
Yeah, and then AI should pop up. So let me go to the main menu. Let me quit. So you can see like everything from the HUD to shooting, all those things are all coded up, and it's something that we take for granted if we ever play games. But we have to actually access each of these parts. So you can see that each of these art assets are assets that we can see right here in the World Outliner. We can go to the main hallway, we can go to the trash cans, but each of them are carefully placed by people. And we're going to have to painstakingly do this work until, if you really want to make an open world MMO game, they use the process known as procedural generation, where they use code to actually generate new levels and characters, and AI, but they're using predefined assets. But for our purposes, we're going to have to do this all by ourselves for this tutorial game. So this is how a shooter game is played, and instead of playing in a standalone game, I can actually play it straight from my viewport. So you can see that this is still, I'm not launching a separate instance, this is all happening within the Unreal Engine viewport, and you can see, like, in terms of, you can quickly iterate and play the game while you can see all the assets and how the game would go. So that's the shooter game tutorial, and this is something that's a little bit closer to what we're doing. Hell, I'll show you guys a vehicle game just because it's fun.
Oh yes,
but
that's what I was gonna ask.
But there's a lot of sample games that they have, but these are the three most important: is the vehicle game, the shooter game, and then I'll also show you the action RPG, which is much more relevant for our purposes.
Right.
But I'm just going to show you the vehicle game because I just think it's really, it just shows you what the Unreal Engine can really do, and it's fun. So why not? So you can see my little vehicle here, and then you can see me driving, and you can see it like in terms of environment rendering. You can see like a lot of the world is built up to a certain point, and then it turns into blackness after a certain point. So you can actually see this in this screen. So let's exit out this track. So
Yeah, can you maximize? If you can.
well, I can maximize the viewport, but I also want you to see like all the different assets that we can put in, and you can see the UI here, the HUDs, and I want to see, and you can see like how the world is built out, and you can see like you can do this all within the Unreal Engine. So very powerful engine. You can see all the skeleton meshes, and you can see how the world itself is just like a box, and then everything past the box is really images, static images. But you can see the sky moving, and those are all done by blurring. So they really achieve a cool effect of the skies moving by doing visual blurring. So that's the shooter game, and I will show you something that is a lot closer to the tutorial that I built, but I think it's useful to see exactly what the Epic Games developers did in order to build a sample action RPG. And you can look at the code, you can look at both the Blueprints code and the C++ code, but it is overwhelming at the very start, so I wouldn't recommend just trying to learn the Unreal Engine by just looking at these sample games, but really trying to follow some basic tutorials and build it from scratch, which I'll show. So let me show you the standalone game version of the action RPG. And this bar, all of these are painstakingly have to be done by ourselves. So you can see this brief intro is using the game sequencer cinematic. So they're using all in-game graphics, and that really helps the
Oh wow,
immersion.
that's awesome. That's like Lee's game, like on steroids. The one that super well
So
done.
you can kill this little, I think this is a goblin. But the cool thing about these sample games is that you can actually see all of this code and all the graphics rendering for this particular game, and you can see it. So that's, and you can see the HUD and all the interfaces.
Sounds like you could cheat.
Yeah. So, and you can see, for example, you can see the items here. You can see the C++ classes that are used, and you can see like the weapons, the weapon assets that they use here.
Share for the C++ code.
Yeah, I'll get into that once I get into my own, because I'm not too familiar with how they actually wrote this game, although a lot of the patterns are very similar. So what's really cool is that, so Unreal starts from the game mode base, and the game mode base is really what governs all the rules. And then each individual object that you can place within this are called characters or pawns. So you're placing actors or characters, and they can be weapons, they can be potions like this. For example, with the potions that are placed here, the pick up health, these are all actors, and they follow a lot of the same code as the character that we have based here. And we're placing these assets into the screen. So that's what a professional, an actual professional level game is made. So let me show you what I've done so far for a single player game. And this makes a lot more sense to me because I actually built it up following tutorials. So it's a lot easier to iterate, but it's definitely not following best practices in terms of trying to make this as scalable as possible. So let me demonstrate to you what I have. Okay, so let me play this from standalone.
Hey,
So-
Evan, can I ask you a question? I'm sorry to interrupt again.
Yeah.
No, I just wanted to know when you try something new like this, right? What's your thought
Yeah.
process behind it? Like, if you're not reading documentations, for example, something that you always
I would follow the tutorial.
the tutorial. Okay,
well,
all right.
Yeah, there's a lot of tutorials that make this. So let me just demonstrate the game. So myself following this tutorial.
Mhm.
Not sure why the HUD is showing here, but let me play this as standalone. I think that would help. So you're selecting a class, but the HUD is showing up. So you can see that the game is a work in progress. So we can select a magic character or a melee character. We're selecting, let's say like we select the magic character. So the magic character we have here, you can pick up items and you can see the health is increasing incrementally, it's regenerating. And then I can cast a spell that recovers but reduces my mana, which is the blue bar on the top left. And then you can see me try to destroy, and I've made the AI follow me around. So those are all, I'll show you like the basic blueprints that are used to do this. And then you can see me casting a spell and trying to attack. Yeah, and then you can see them dropping off the loot.
That's awesome.
And then when I pick up the loot, I randomized it. You can pick up 43 gold. And then you can pick up 14 gold. And then you pick up this gold. And then there's an inventory of these boxes. Press B, you get the inventory. And then when you pick up this item, it just pops up. But you're picking up wood, essentially. So... and you can see like my experience is given by the bar below, by the purple bar below. And you can see my level in the top left is level 4. So all those things are saved. So there are certain variables that you want to save, and that includes, of course, your experience and your level. And you have to tell the machine to remember those variables for saving. And then when I walk into this little quest pop-up, you can see my HUD is a little bit messed up right now. But you can see in the top right is my current quest is go find a quest. And then if I walk through it, it's going to change to begin a hero's journey. So then you can see that the quest has changed. And so that's for my magic character. Now I know why the HUD was messed up. I need to change the world settings here to none. And now I'm going to play this as a standalone game.
Dude, why is inventory bound to V and not I?
This like, so I was playing around with this engine trick before. So V not to I. No, yeah,
Revolution.
yeah. I mean, I don't know what these key inputs could be. So,
I'm just yanking your chain, man.
all right. So the HUD is not supposed to be showing up here, so it seems to be reduplicated because I believe it's something. I was playing off the game modes here. Oh, and I think this will actually fix it. All right, so now we have the clean character selection interface. We can select the magic character, which you guys already saw, and a melee character. So let me select the melee character. So the melee character is same functionality. So the tutorial was pretty bad because I had to build the melee character from scratch to mimic the magic character. But what you want to do is you want to do inheritance from a basic character mode, so you don't have to reduplicate the code. But it's good just to get the experience of blueprints, which I'll show you guys. But you can see that the character has basically the same functionality as the magic character. But when I press 1, now I'm swinging this big giant sword around, and I'm chopping up some fools. And each of these enemies have 2 health. You can see my experience bar in the purple increasing, and you can see me level up after I chop this fool. And you can see me, I've reached level 5, a pop-up. So each of these pop-ups and each of these widgets, you really have to build from scratch. And you can see, so that's basically the fundamentals of the gameplay. So let me actually show you the blueprints and and the code. So each of these melee characters and simple AI, you can see the player start is given by this. Where is the start in the world outliner? So it's coming from this object, and well, now it's a bad size. So you can see that my characters begin from here, and because the way I've coded it is that it would render the melee character or the magic character depending on the character selection screen you saw. If I wanted to put in more AI, I could just simply drag up my simple AI objects, and I'm just building up more monsters here. And then when I actually play it, and let's say do the magic character, you can see the monsters automatically materialize. So this is how most designers and developers actually use Unreal. They would develop the blueprint classes below, or the assets below, and then they would just pop them up in the screen in the viewport. And that includes art as well. So let's actually take a look at both the magic and melee character blueprints. And then you can see how the basic mechanics work there. I think it's worthwhile to note that the blueprints themselves are a way for designers and developers to quickly implement gameplay mechanics without resorting to code. So it's really useful for not only people with non-technical backgrounds to quickly get logic started and implement models and characters, but also a way for developers themselves to quickly iterate, do only the critical functions and efficiency optimized code in C++, but use blueprints for for the basics, things like mouse input. So if you do your mouse input, you can see like it's actually acting on certain other boxes. So let's, for example, look at the health regeneration blueprint. So you can see that every single event tick or every single time a frame is being rendered, we are encountering a sequence. You can think of this as a switch case if you're familiar with the code analogy. And then if it's 0, we're going to delay. And if our health is less than 1, the health variable. So you can see that my character has all these variables that I've made. So you could so think of this melee character as a class or a class object, and that has all these host of variables and has these functions or blueprints that happen as a result of events. So based on every single event ticking, I'm going to pipeline it into a sequence that if it's 0, it's going to regenerate my health if it's less than 1, and it's going to keep incrementing it by my health regeneration rate, which the default is 1%. And then it's going to encounter an if-else branch, and if the health is indeed greater than 1, it's going to set the health back to 1 so that you won't have health greater than 100%. So the mana regeneration is coming off the same sequence, so that every single time there's an event frame, we're going to regenerate our mana by 2%. Only if our current mana is below 100% or 1, and if it is indeed greater than 1, then we're going to regenerate our mana rate by 2%. So we've covered variables, and we've covered health regeneration and mana regeneration. So let's actually look at the input abilities. So every time I'm pressing 1, if you remember in my magic character or my melee character, my magic character was casting a ranged lightning bolt, and my melee character is swinging a sword around. So you can see here that every single time I press 1, it's actually going to swing the sword around. So if I press 1, and I've mapped the input action ability to pressing the number 1, that if the condition of the ability 1 cooldown is greater than 100% or 1, then the branch is indeed true, and I'm going to swing the sword around. And once the sword is swung around, I'm going to set the variable slashing to be true and the slash sword variable to be true. And then there's a delay for 1.5 seconds, and then I'm going to set both these variables to be false. And then I'm going to set the ability 1 cooldown to be 0, so that the player won't spam a swinging sword around. They have to wait for the cooldown to actually finish. And once the cooldown is less than 1, then we're going to set the ability 1 cooldown again, and we're going to increment it by 5%. And then there's a delay of 0.01 seconds just to make it look prettier. So that's swinging a sword around is setting up these variables to a boolean that I'm actually swinging a sword and I'm actually slashing, and then there's delays and cooldowns. As a reminder, you can see the cooldown every single time I swing the sword. If you look at the icon in the top, in the bottom left, you can see my sword icon immediately cool down. You can see it immediately regenerate, so I can swing my sword again. So that's the melee character swinging a sword, and then opening the inventory widget. You can see that every single time I press, I've mapped this to the hotkey B. So every time you press B, it's going to execute this particular event action, and it's going to create the inventory widget. It's going to add it to the viewport, and it's going to cast it to my particular play controller, and it's going to allow me to immediately show the mouse cursor. So you can see when I play the game, I press B, you can see my mouse cursor pop up. And then when I press X, you can see the mouse cursor disappear. So even little things like that, all those things, you have to map it out. And it's a lot easier to use blueprints. And blueprints themselves even have things of class inheritance. So let me show you the melee character. I think it's always interesting to see how the animations happen, because there's a lot of things that go into it as well. So if I go to the melee character and I see my skeletal mesh, you can see that this is my skeleton. And if you want the sword to happen, if you want the sword to pop up in this particular circumstance, you actually have to denote at which point you want to have at which point you want the sword to show up in, and it's a lot easier to use if you actually have the skeletal mesh in place here. So you can see that this character model originally did not have the sword attached to it, and the sword is actually a separate object. So you can see the blueprints here, and then the weapon sword looks like the viewport here, and you can see my sword is actually a separate entity here that I've had to attach to the paladin mesh. And then you can see in terms of animations, so you actually have to create what's known as a blend space so that the paladin is walking in these two directions of automated to negative 180 to 180 degrees. And then when you turn left, he's going to turn left. You turn right, he's going to turn right. And then if you increase speed, he has to do the running animation. And there's a lot of other cool animations that you can see. So for example, this is his jump animation. And these are, I've just downloaded these assets, and this is his draw sword animation. But the thing is, you can combine these assets to actually particular gameplay mechanics. And it's done through the blueprint for the animations here. So you can see that this is the output pose for my melee character. You go into the state machine. Right now he's idle, and I had to create these movement, sword action, and jump animation sequences. So let's actually see the sword action. So in the sword action sequence, I'm playing the animation, play sword and shield, this animation right here. But otherwise, his default pose is running, and in terms of direction, in terms of speed. And you have to create this if you want the paladin to run and then fight and run and execute the sword action at the same time. The paladin does not do this like idly. Otherwise, the sword, the slash animation and the run animation will not occur simultaneously unless you create this blended animation for this particular state machine. And you have to create mappings that when he's idle and he attacks using the sword, he's going to go back from sword attack back to idle. So these are what these two arrows represent, so that it's bi-directional. So that's the melee animation blueprint. And just to show you how unwieldy it can get, I also have to create this for the magic character in terms of her animation blueprint and you can see it's very similar to the melee character, but now instead of using a sword action, she's using a casting for both the healing and in terms of, so this is her healing animation, and in terms of her attack animation, she's doing the combat animation here. And just as a reminder, let me show you. So this is her healing animation. You can see it pop up, and then this is her attack, her ranged attack. So you even have to hook up, for example, in terms of where that for the magic character, that her spells are casting from her right hand, so it just doesn't pop out from somewhere like out of nowhere. You have to really hook up that her.
When you mentioned abstraction with these blueprints,
Yeah.
are you able to use abstraction? Like, how much code duplication do you need for like the paladin's casting animation versus the mages?
Yeah, so
Oh my God,
I
that
really
Lee?
think. So I think in terms of the
Okay.
casting and the melee, it really has to be. I think like characters should have a core set of actions, and that core set of actions should be casting and fighting animations. So, in terms of interfaces with blueprints, I'll quickly show you what I've done so far. So you can see that this weapon sword is a weapon, and you don't want to. In terms of how Unreal acts, you want to make sure that each weapon you have has their different view. So of course the sword has its own unique view, but what you don't want to do is you don't want to create a separate event graph for each weapon. You really want to have an interface so that's very scalable, so that your designer, once your designer or you have done making or downloading a weapon asset, that you would have a common set of actions that you can apply to all weapons. And that each character will equip the weapon in generally the same way. Like a sword, there probably could be 500 swords, but they're not going to differ much in terms of how the player character that you're using and how he or she equips that weapon. And you can see here that in terms of this particular sword, let's see. You can see here is using an animation blueprint. It can use an animation blueprint here. And let me show you in terms of how my melee weapon. So you can see that. So this is a BPI weapon interface. And this interface is being put into every single weapon. And if I show you the simple AI blueprint, this is the so you can actually have functions and whatnot for each of these blueprints so that they're executing it. So, okay, so you can see here, ignore my comment here. So every single time, so in terms of gameplay mechanics, what we've done here is we actually cast the damage, the object taking damage within the AI object's own event graph, so that every time a weapon overlaps or collides with the simple AI, if they collide with an item that has a BPI weapon interface, then they're going to take damage, and it's going to set the slashing variable to be true, and then it's going to deduct 1/2 of the health of the AI, and then it's going to execute this def function, and this def function is just a blueprint itself, where when the AI is dead, it's going to execute a loot pickup, so you can see the loot bags drop off, and then you run through all these all this code, and you're going to set experience so that my character would get experience, and once it hits the max experience, it's going to level up. And once it levels up, it's going to update numbers in the HUD. So let me show you the HUD interface as well. So this is my HUD interface, and you can see how each of these boxes are independent of each other. And you can see me casting spells here in slots 1 and 2. But this is definitely not the scalable way of doing it. Instead of having each individual box being binded, you can see here that there's a binding between different UI elements and the code. What you should really do is have an array of different actions, and then have one of these actions or two of these actions for the magic character be casting a spell and healing, whereas melee characters' actions are to do melee action. And you can see, like, for example, here, this text is binded to this get text, so that it would so it would show my levels, and you can see my health bars here are binded to the get health percentages, and that's one of the basic HUDs. And you can see, for example, the inventory HUD is very similar. Each of these items are binded to your current inventory items. And even the class select interface is a binding of these characters to their animation. So that's why when you do select a class, these character models would be animated. And so that's a single player. I want to move on to the C++ quickly, and also I'm cognizant of the time, and I do want to get some discussion in. So let me just show you quickly how a multiplayer RPG would happen. And this is a tutorial I followed from the Unreal documentation. And this is how multiplayer would work in Unreal. And this is all done, well, mostly done by C++, but you don't want to do one or the other, although you could build games in C++ only or blueprints only. In terms of what Epic Games and Unreal recommends, it really recommends a blending of both blueprints and C++. So let me show you the basic functionality of a multiplayer game. So let's start it out. Let's see if okay.
Oh.
So, well,
That's cool.
I want you to see, because it's actually going to show it in both the server and the client. So I wonder why it's not showing both characters. Let me see. Open project. So it's going to show up two windows of both what's the server character and what's the client character. And in multiplayer RPGs, the clients would send back information about of updates to the server model, and the server model is going to update their variables and replicate it by sending it straight from the server to the client. So let's see if this works. So you can see here I have 2-player starts. I wonder why it's not showing the third person.
Is there a notion of containerization for like helping you deploy and simulate multiple characters as if they were coming from different machines?
Interesting.
Let me see if this is multiplayer RPG. No, yeah. I was opening up the wrong project. So this is the third-person multiplayer demo that I built like 2 days ago. So let's show. Okay, so you can see here I have 2 screens, and this is the client window, and this is my server window. Let me actually make the screen smaller so we can see both side by side. All right, so if I click on the client view, you can see me casting this fireball, and you can see me run in front of the other screen, like so, right? And then if I cast the fireball to this character, you can see that third-person character 0 has 80 health remaining, has 70 health remaining, has 60 health remaining, has 50 health remaining. So you can see the server acknowledging the updates and updating the health variable and pushing it out to all the clients as a result. So, let me also do it in the other way. So you can see me running in here, and I'm running it from the client here. So this is a little bit confusing because in the tutorial they place the server has their own character as well. So this is not 2 clients. although it looks like it is actually the server and the client. But you can see the server has the same functionality as the client. And you can see me casting a fireball, but instead of character 0 now having 90 health, you can see character 1, which is in the client, has 70 health, and it's getting wrecked accordingly. So let me move to the client, and then you can see me as the client sending it back to the server, has 90 health, and you can see character 0 has 70 health, has 60 health, has 40 health, and then let me go back to Unreal, and then you can see me sending the fireball back to character 1. They have 40 health, they have 30 health, they have 20 health, and now they have been killed. So that's how the basic functionality of the multiplayer is in terms of being rendered on the screen shows like. In terms of C++, you can see the third-person character. So I can click on the asset directly. It's going to open up the it's going to open up Visual Studio, and we can see the C++ code. And there's really 4 files that make that tutorial happen. It's in terms of character, projectile, and game mode. So you can see here, I'm just going to go through the header files because you can just see the actual methods. And you can see that the projectile itself is made of a sphere. It has a static mesh. It has a particle system in which it explodes, and then of course has a movement component. And you can see it deals damage. And it begins when the game starts, and then it's destroyed accordingly. And in terms of the actual C++ projectile implementation, you can see me just overriding each of those functions. And then the game mode is just the basic class that rules over all other things in terms of setting up gameplay mechanics. And the other 2 important files are the characters themselves. And if you look at the third-person character interface or header, it defines a class where we're going to implement these functions of, for example, the third-person character has an arm component, has a camera component. Those are boilerplate. But the most important thing is that it has lifetime replicated properties. And replication is really the key word in multiplayer, because a replicated variable, and it only goes one way, it's the server sending variables to each of the clients that are playing the game. And the server is the single source of truth. So if a variable is marked as being replicated, that's really what the server is keeping track of and is sending back to the clients. And you can see here that the health is being replicated and being updated accordingly. And you can see here are the getters and setters for the health. So also, I wouldn't be alarmed by these U functions. So Unreal has a lot of these custom properties that they add on to base C++, because otherwise there couldn't be any reflection in C++, where the code actually acknowledges what the other code is doing at runtime. So these U functions are necessary for Unreal to recognize that these, for example, are blueprints, and that we can call these C++ functions in blueprints and vice versa.
I'm sorry, can you zoom in a little bit, editor?
Like here?
Yeah, oh, awesome, perfect.
Yeah. And you can see here that these are the moves. And then you can see here that these are the player input components, and these are the projectiles that we're firing a weapon, booleans that we're setting up. And in terms of actual implementation of the code, it looks like this, where we're setting up the character movements, we're setting up the camera. These are all boilerplate. But this is really the interesting stuff, where we're initializing the player's health to be 100%. And we also are initializing the fire rate and the ability to generate a projectile, the fireball. And here's input boilerplate, and these are movement boilerplates. And then here is we're starting the actual, that when I click the left mouse button, that we're actually generating the fireball, and that we're handling the implementation. So Unreal uses RPCs so that we will actually be calling the actions into servers. And the action in the server is that it would actually be getting the information about the health being decreased as the characters are being hit, and that the character is taking damage, and also being able to acknowledge, and each of the clients acknowledges, for example, that an explosion has happened. So those are all things that we have to keep track of in a multiplayer game. That even the explosions, the clients have to be able to acknowledge and like see an explosion happen in other clients. So that's the basic C++ overview. So I just want to quickly talk about, we already went over this, but I think we're getting close to an hour, but I just want to spend like the last 5 minutes or 10 minutes really having a short discussion over not only just things that I've talked about, but also things of interpreting code at runtime, because I think part of the dream is be able to have a programmatic interface for these kinds of MMORPG games, and how to hook up multiplayer in a very scalable way, which I've showed. So I think we can leave the rendering and the multiplayer for another time. But I think the key question is really how to interpret code in the game at runtime. And in terms of embedding a scripting language, Lua and Python are very popular, so that you can actually execute code as a virtual machine while we're playing this game. So you can see that I'm playing this game, and let me show you the standalone game. And this is inbuilt to Unreal, is that you can actually execute an in-game console. So you can see the in-game console pop up when I press tilde here, and you can see me actually type in commands here. If you guys ever played a game, so you can see all these like Unreal mechanics here of functions. And these are all really built for developer debugging purposes. But it would be really fun if we made a game that players can script their own functions and do some like attacking automatically or casting a spell after passing a few conditions. And it would look similar to this in-game console, but it's definitely doable in terms of embedding a scripting language inside this game, inside the game itself, so that the player wouldn't be pressing compile, or it would just be running in the same executable. So that this character, for example, will automatically cast Fireball once like the cooldown is finished. So that's the question that I have. But is there any other questions in terms of that, or any other things that we've discussed so far?
I have a question about like just the blueprinting from before. One more thing, you showed this like big graph of killing or like attacking something, and there was this part of the graph that was like you gain experience if the thing dies, and maybe you level up. But then there are other things that you can do maybe to get experience. Is there any way to like generalize stuff like that? So like the experience and potentially leveling up subgraph can be reused between like, getting a quest, killing a creature, whatever else you do to get experience?
Yeah, so let me show you the part of the blueprint. So this is like very basic and definitely not optimal. So I'm actually setting the experience for the character being generated, not even in the character object itself, but in the simple AI. So in those enemies, those monster critters that you saw. So this is the monster critter object. And the experience is being set at the third person level in terms of if it's greater than, if it's hit the max experience variable, then it's going to level up accordingly. But this is definitely not the way to do it. I think embedding experience as part of each individual character is the right way of doing this. But the way of doing it here is just a very quick and dirty way of that. When the simple AI dies, it's going to execute its def function, and inside its def function, it's going to increment the experience. And the experience itself is not even embedded inside the character, it's embedded inside the third-person game mode. And you can see the third-person game mode is here, and it applies to every single character. And you can see the experience here and the max experience here. This is fine for single player, but obviously for multiplayer, you want experience and max experience to be set at the player level, not at the general game-wide level. So in terms of making it more generalizable beyond just a monster dying and the player getting experience that way, that's definitely doable. It would just basically be incrementing this experience variable, which is saved, and you can see these custom, not these custom, these boilerplate Unreal saving nodes. So you can see, for example, Unreal has all these boilerplate blueprint nodes and functions that you can call upon, and you can see that Unreal has, for save game, it has creating a save game object, deleting a game in slot. The save game exists, the load game from slot, and saving game to slot. And you can see me implementing these save games to slots here, where you're actually you're saving up the. Let me show you the event graph. So you can see that I'm checking to see if the save game exists. If it's true, we're going to load up the game from the slot that's named XP. If it's false, it's going to create a new save game object. And you can see me saving these three variables: experience, max experience, and level. So obviously, these variables are very important in terms of persisting the experience of a character. But there's nothing that prevents us from creating code that increments this experience and maintains the max experience and level, aside from killing an AI enemy. Does that make sense?
Yeah, that makes sense.
Edwin, how did you tell the AI to follow you? Like, do you need to teach it to go up the stairs and down the stairs, or you're just
No,
told it to follow you, right?
I'm just following this. Okay, so
You jumped. You didn't go up the stairs, but they went up the stairs.
yeah. So here is so this green spot here is the navigation mesh. So this tells exactly the areas that the AI, that for this particular simple AI object, exactly where they're supposed to navigate to. And even though I've expanded this nav mesh to include up the stairs, they weren't able to go up the stairs because I believe the simple nav mesh has this blocking. I didn't include the stairs as a result, so that's why they're not able to go up the stairs. But this nav mesh represents the navigational area that they're able to traverse. And then if we go to the simple AI blueprint and we go to their event graph for the simple AI, you can see I've implemented AI here. So on seeing a pawn, so my character is a pawn, but this is very basic code, so that if they see any other pawn besides my character, they would actually do the same. And you can see that once they see a pawn, they're going to move to the character. And then you can see here is another move to function where every single time there's a frame, an event ticking, there's a delay for 2 seconds. And if the AI is currently not moving, it's going to set it to be true, and then it's going to go to the pawn. And let me show you the viewport here. So this, you can see the pawn sensing is here. So this is actually, they're able to see everything on this side of the screen. This is what this pawn sensing says. So that when you go to the event graph here, once they see the pawn, they're going to move to me, to the player character. But I can actually minimize this pawn sensing to less than half the screen here, because that's probably not very realistic, even though this wolf thing probably does have like peripheral vision or something. And I can actually minimize it. Let's see if I can actually scale this down. So the sensing interval, let's see if I can minimize the hearing interval. So they even have hearing. So you can see that the blue thing represents what they can hear. And you can see me expand it all the way that they can only hear within my immediate vicinity, or they can hear all the way out across the entire map. but I haven't implemented any sound mechanics in terms of collisions or whatnot, so the hearing isn't as important. But I did implement the seeing on sight of a pawn it's going to see. But now you can see me decrease the sight radius, and you can see the green turning a lot smaller and smaller and smaller. And that's exactly how, so that when I click on see pawn, it's going to move to the pawn. But let's say that I made him, let's go back to the pawn sensing component of the AI. I've made the seeing to be very small, so let's, and let me actually decrease so now you can see the peripheral vision angle. I'm also decreasing the peripheral vision angle. So now they can only see this very small cone in front of them. Let me compile this, and let me play. And let's see, if you remember from before, they were immediately able to spot me and then follow me. But now they can't see me at all until I'm very in front of them. And then once I'm in front of them, they're going to jump out. They're going to follow me. Well, not even, because now that you can see that their sight is very limited now. So that I have to go very, very close to them, and still they're not going to follow me. But whereas before, if you remember, they were able to follow me almost upon the game starting because their peripheral vision was so big. But let's make this a lot bigger and the sight to be a lot longer. And now let's compile this and let's play this again. And now you can see the guy following me around when he sees me. And now you see them both follow me around. So that's exactly, so if you ever played like, I mean, it's been a long time since I played like a game like Hitman, but when I was a kid, I used to play this game Hitman where sound and sight of the enemies was very important to the gameplay mechanics because you were a hitman and you're trying to run away from the enemies. But that's exactly how you can make a game like that in which the AI is limited in terms of sight and sound. And
Just one small thing, using, like, when you keep saying AI, is it learning anything by itself, or I don't know if that's the question we asked, or just it's just for that.
Yeah. So this AI is very basic. So it's very it follows the rules base. So if you just think of the AI as just like another character, so let me like for example, this is just another character that I'm putting into the screen here. So I'm putting in multiple AI here. That it's very dumb, so that only when they see a pawn or a player character, they're going to move to that pawn. So there's not much. They're not. You have to implement, for example, combat mechanics or more of like if you want to do more fancy AI combat or AI moving or intelligence, you really have to implement them from scratch. But right now, the AI is just is only when they see a pawn, they're just going to move to. They're going to move to that. They're going to move to that pawn, to the actor. Does that make sense?
Yes. Thank you so much.
Yeah. But that's, so let me show you, for example, in the blueprints, they have all these basic AI components. So they have making noises, they have AI directions, and they have perceptions. They have actions here, they have navigations. Obviously, we've used the pawn sensing. So these are the basic AI blueprints and nodes and functions that Unreal gives you, but you can always, of course, make your own custom functions and blueprints in C++ or using this interface. So, yeah. Any other questions or discussions?
I think the discussion is great, so I do want to hop to that. But one of the things I was curious about was how you combined the sword and the paladin, and how the swinging of the sword actually worked. So was that like a UI that was on the paladin, or did you have to do something that was a combined effort?
Yeah, it was a combined. It's a combined effort. So so first you have to create the sword here.
Yeah.
So you can see the sword is a separate blueprint class. And you can see it has its own box collision component. It has its own skeletal mesh component. And you can actually make, for example, the sword have a bit. So you can make the sword have a, not like that, but if let's say I scale the box, so the sword can actually damage more components if I make the box bigger or smaller. So this is the box collision, and
it's a very wide sword.
Yeah. So that would be like, this would be like a very magic sword. So I'm like 10 feet away, and then it's going to collide, and then you're going to detect a collision.
Is that a sword?
Once you swing it. So that's why you have to set all these variables. Like that's why I said, if you remember, the slashing variable in the enemy, so that I wouldn't. So otherwise, if I swing the sword around, it's going to damage 3 enemies at the same time, which you could do. And but if you want to make sure it only damages 1 enemy at a time, you have to set this certain like these helper variables to be true and false only during the duration of the sword swing. So this is the weapon sword, and then if I click on the actual animations for the melee character, and let's see this paladin character. So if I go to the skeleton tree, so this sword is actually, you can see that I've created a custom skeletal mesh called weapon hold right hand. So all these other left hand, left arm, spines, all these came with the character model. And most character models have like these right shoulder, right arms, and you can actually like tilt them accordingly. So so right now I'm tilting my my right forearm, and you can see it tilting every other dependent component. But obviously it doesn't look so right, so I just keep it default. But one thing I had to do was I had to create this new special socket called weapon hold right hand, and then inside this blade, right, I had to create. I'm using the skeletal mesh of a sword that I've just downloaded, of the same sword that you guys saw, but this is the actual art asset that I downloaded because I didn't create the sword from scratch. I just layered on code on top of it, or blueprints on top of it, and you can see the actual skeletal mesh of that sword. So you can see that this Black Knight sword is independent of the actual melee character paladin model, and I had to add it on top of it, the paladin model. And so that's just the mesh. This is what it looks like in terms of just the GUI. And let's say I want to open up the weapon hold right hand. Let's say I want to make the sword really big. So I saw videos of the new Final Fantasy, and the main character has this ridiculous giant sword that I thought was just utterly ridiculous. So let's make it like that. It's like a ridiculous giant sword that looks like this. So let's save it and let's compile it. So you can actually see this correspondingly. If I play it, now you can see I have a giant sword here. So now when I swing this giant sword, and this is actually like a real new game just came out where the main character is carrying this giant ridiculous sword out, and I've always thought this was like overcompensating or something, but it is.
It's a bug, Evan.
So that's how that animation works. I mean, that's how that mesh works in terms of rendering to the GUI. But like, how does the character actually know to like swing the sword around? And we actually have to go to. So these are the animations that the blend spaces where if the character was like say running or like, and then you could play around with blending different animations together in the screen. But in the actual blueprints, so this particular character has their own animation blueprint. So this is separate from the blueprint I showed you, where if you press number 1, he's going to swing a sword around. He's going to do this. He's going to set these variables to damage and whatnot. This animation blueprint is another blueprint that is separate from that gameplay blueprint. And you can see in this animation blueprint, the output is output pose, where he's just idling around or attacking or jumping. But if we go into the state machine code, you can see that right now he's idle, as we see in the screen here. But he also has movement. So this is his walk-run blending. So that's when he's actually moving in this particular state machine. And then you can see him jumping, and you can see that he can jump from either an idle position or from a movement position. So if you don't want to make him jump while he's running, you have to disable these connections. So right now I have an is falling variable that tracks whether he's falling or not. And if you want to make him jump while he's moving, you have to hook up these this particular animation blueprint where he can both jump and move, and sets the variable is falling accordingly. And then it conversely, when he's going back from jumping to moving, the is falling variable is set to false. And then, of course, you can also jump when idle, but you have to hook up. You have to create this jump node where I'm playing this animation jump up and down. But in order to get there, he can only get there from an idle position or from a movement position. You'll note that he cannot jump I haven't hooked up like him jumping from a sword attack animation. So that's very so it's very interesting to see like different states he's in. But this is your quintessential basic state machine where he can only occupy one state at a time, but he can move from one state to another state based on what these arrows, whether he fulfills these conditions or not, based on a particular animation to that animation. So does that make sense?
Yeah. I mean, so it sounds like if you want to do like a bow and arrow thing, it would be magnitudes more complicated than like a sword.
Yeah. So I'll show you. Let me just show you again the magic character, who does have a ranged element. So let's go to the blueprint. So the magic character. So she has her own animation blueprint. Let me go to her animation graph. And now you can see that she has a casting 1H, which is her healing spell. So let me play you for that. So that's her healing spell, as you guys saw when I pressed 1. And that's her animation. And then I spawned this magic effect as the area of effect, if you guys remember. And that's that animation. So 1H. But then her combat is, so she's sending in this ranged combat attack. But you have to make the projectile pop up, and that's done through the gameplay mechanics. So let's see, for example, the magic projectile here. So you can see that this magic projectile is very simple. It just has a projectile movement component, and I've added in this little magic thing, this particle system that spawns this little comet effect that I downloaded, this projectile effect here, but I can change it, for example, this particle effect to be an arrow, like an arrow poster or something like here, or let's change it to like fireball or something. Yeah, let's fireball charge. Well, that doesn't seem to be. Let's just change to fire. Let's compile this. Let's play. All right, so that's the healing animation, and now I'm casting this little fireball. So you can see that these animations are very plug and play, but you have to modify the actual projectile itself, not and then you're just hooking up this particular magic projectile to the blueprint for the magic character to cast this particular projectile. Let's see. Where's the third person character? So you can see that I'm casting the spell 2 here, and then I'm spawning the magic projectile class here that you guys saw. But you also have to remember that you also have to hook it up in terms of that particular animation in the animation blueprint, so that you're playing the particular animation you want. So there's 2 blueprints, really 3 blueprints that are involved in casting a ranged thing. You have to update third-person blueprint, then you have to update the animation blueprint and hook it up to the state machine for the casting 1H combat. And then you also have to, of course, create the projectile class itself. Any other questions?
How does a thing like blueprints, like how does that scale? Like if you're building like a AAA game or something, or maybe like, maybe not that level, but do you ever just like get to have so many blueprints that you're like, there's got to be a better way? I mean,
so I think a blend is really important. So I think in terms of, so blueprints are very interesting things because, for example, let's look at this weapon sword. So this weapon sword blueprint has the weapon interface to it. So even though it's a blueprint, it actually is an interface to something else. So that's very interesting to me because it shows that you can have blueprints and you can even call functions inside blueprints themselves. So let me show. So inside, for example, here I have like a construction script function. Call it. Let me go to simple AI. So I have a take damage blueprint for the simple AI where once it dies, it's going to emit an explosion, and then once it's dead, it's going to spawn some loot. So I think in terms of like basic gameplay mechanics there, and you can even hook up multiplayer in blueprints. I think it's I wouldn't do like a all or nothing C++ because especially when it comes, for example, to like animations and having individual weapon arts and assets and having different enemies, it's very easy to hook them all up to blueprints, and then treating them like as data assets, so that every time you add in a new weapon, you still have to, like, for example, modify the weapon's collision and do all this stuff that you can only do in the GUI. But for, I would say, essential gameplay, you would want to write that in C++. But I don't think it's either or. It's really, they really recommend doing a blend of both. And blueprints have inheritance as well, and has functions and interfaces. So there are things that you don't have to be duplicating. You shouldn't be duplicating stuff for every single character or for every single weapon or for every single level. So yeah, let me just before I so yeah, I think everybody is bored of this like gray area. So let me just let me actually put these monsters and my characters inside an actual nice map. So I think everybody wants to see nice maps. So don't save. So you can see I'm starting here. So okay, and this is really the power of Unreal really come to life. So I can put all these monsters in this nice map, and I didn't even exit my screen. All I did was just click on a folder and open up a level. And now I can put, like, let me see, let me put some simple AI. Let me put bulbs here. You can see this like really cool map interface. It's like playing a game to make a game, really.
Yeah, it's like Minecraft creative mode or something.
Yeah. And let me start with the melee character. And you can see me play the game. I'm not even exited the screen. So now you can see the 3 little wolves running. You can see me with my giant sword. And now you can see this really beautiful, nice level. And you can see all these art assets here. And you can see this collision. Each of these things is collision. And then you can see this really nice interface. So once you create like this basic third-person character, you've created the giant sword, and you've created these simple AI objects, or more complicated objects. And I could even put, for example, the health pickups I did earlier throughout this map, and the quest thing that I did throughout this map. You can see, like, once that happens, you can easily have separate people create the levels, from people creating, like, the AI and creating the melee character. And then you can see, like, all the mechanics that I did before in terms of cooldown of the weapon, my levels, my health bar regenerating, my mana regenerating. All those things are all, I didn't have to change a single thing. All I did was just change the level itself. And you can see me still, you can see the enemies still dropping off the loot, and me finding all the same gameplay mechanics, but now in a really nice level. And you can see it, like, there's a real separation of concerns between both the gameplay blueprints and C++ with the actual level creation. So not much, of course, when you're hooking up levels to levels, that requires some work. But in terms of just popping in all your actors and all your pawns and all your objects into a separate level, you can do that within seconds. So yeah, that's, if there's no more other questions, I'm sure we can do more. We can do more of the discussion next time or next week. But obviously, there's a lot of cool things to learn. But I don't want to take up too much time. So if there's no other questions.
Thank you, Edwin.
Yeah, this is really cool, Edwin. Thank you.
Thanks. I enjoyed that.
Yeah, I think we have a lot to talk about with this.
Do you guys want to talk about it now, or do because it really comes down to
Someone else prepared another thing, right?
So yeah, so Evan prepared. We've been texting, and he mentioned that he's comfortable doing it next week. So it really kind of comes down to what we as a group want.
Democracy.
I'm just kind of curious how you, like, I don't know, you and Lee go back and forth about talking about how you would put a scripting language external to this kind of thing that a player could interact with. Like, what is the entry point for that to do this kind of thing? Like, do you have any idea yet? Probably. It's probably a loaded question. I'm sorry.
Yeah, like I think so every single game has the game loop, and that's where you're rendering all the assets. That's where you're running the physics engine. That's where you're running the. That's where you're detecting player input. So I would assume that it would be inside the game loop. It would have to be like somewhere inside the game loop, so that it's always going to be ready to detect. Like Python or Lua or whatever code and runs it accordingly. So it's just basically like us pressing an up arrow or pressing like fire or pressing like slash. But instead of detecting just the key binding, it's also detecting that a code has ran and it's going to execute it accordingly.
Gotcha.
And you do that all in C++.
Yeah. It'll have to be like, for example, it's going to have to be inside the source.
Was it got a list?
It's going to be
class.
inside the game loop, wherever the game loop here is in the code here. So, like for example, when you begin play for this third-person character, maybe, but you would want it to be, you want to have it more in a more abstract level. So, very interesting stuff. Like they have C# code to run the C++ as well, so it's very interesting. I haven't spent enough time on this to know where the game loop is, but I assume you would have to put it somewhere in the game loop, because every single game runs using the game loop.
And what do you mean by game loop?
So the game loop is it's like basically a while loop, right?
Oh, okay,
that
okay.
Perpetually runs during the duration of the game executable, and that's where it's able to detect player input, and it also renders and does the AI and physics at the same time, sequentially, of course, but during the duration of the loop, so it makes it seem like it's like simultaneous.
Gotcha.
That's cool.
But I don't, honestly, I mean, it's cool and everything, but I still prefer Python. Like, I still like prefer like, Python stuff then. Maybe because I don't understand much, but don't you? Or like JavaScript.
Edwin's converted. I don't know.
Well, that's why we want the scripting language, so that, like, for example, like a player can write their Python scripts to, like, their character can, run along and fight an enemy, can go locate an enemy, fight the enemy, collect a loot, go shopping, so that would be the scripting language for players. And it's Lua and Python are really the two main contenders, because I've heard of most games use Lua as a scripting language, like Gary's mod. But there are a few games that use Python as a scripting language. But those are only that's for the client side. In terms of actually writing the code, if you want to work with Unreal, you have to use C++ or C# for Unity.
But then also, Tom, I don't know if you realized, my questions especially, it's all like, we have this janky thing, this is how you make games, how do we make this as Pythonic as possible?
Exactly.
So it was like, how can we do this thing? But that's what in my mind, that's what Edwin's been explaining. It's like, we don't want to learn how to do everything. We want to understand what game developers are doing, but it's like, how can we do it in the most scalable Pythonic way?
Oh, okay.
I think a lot of us, like, for myself, for like data scientists at least, maybe not for everyone, because some people like JavaScript. But whenever I'm thinking of any technology thing, it's either like, how can I use this in a Pythonic way, or does this thing do something that Python can't? And therefore I have to use it as is. But you're always trying to use everything like Pythonically, if possible.
Yeah, because I remember when you show your repository, it was a lot of functions, one after one another, and that's why I was asking actually Edwin if you don't prefer like a Python instead of C++.
Yeah, I think also similar to what like Evan asked is like how do we actually embed like Python inside like this game, like a Python virtual machine inside this game. So for example, like you can see here that when the game starts or being spawned, we're going to execute this begin play function, and then like once this begin play function like happens, right? What we're going to do is we're actually going to execute like a Python VM here, and then inside the Python virtual machine, it's basically like running Python in your console. It's just perpetually going to be there, ready to accept any script from anybody, from the player, and then once the player puts in the script and presses enter or runs it, then it's going to execute the code, and then those actions are going to be sent to the server as events, and then the server is going to execute them one at a time.
As an event, okay.
Gotcha.
So I was thinking about this, and I feel like there's almost two ways to kind of go about implementing it. And one is like a really scripting heavy language where you implement like a text box on the screen that you can copy and paste code. And at that point, you have to find a way to take that string, which is how it's going to come in, and then figure out how to interpret that Python code. The other is to like leave a Python file inside of your code base and to find a way to run it, maybe perhaps as like a server, and then to send queries to that server and to try and get that. And I feel like they each have kind of their positives and negatives, because if you implement the server, it's going to like iterating on it is going to take a long time, right? If you're writing a model, you have to build the game every single time. Whereas scripting it, I feel like scripting is like the harder implementation on for like the actual developer for you.
Yeah, like there was an interesting thought I had. So that we would actually like have a full stack web app where it's like a REPL, like leak code.
Yeah.
Where like, and I've never heard of any game actually doing this, but it's very interesting, right? So because of course like client-side scripting languages like Gary's mod, you can write Lua, like World of Warcraft, you can write scripting, EverQuest, you can write scripting in MacroQuest. But let's say you have a REPL like leak code in a full stack web application, and then like players would actually write their scripts inside our website, and then they would send, and then once they execute the scripts, they would send events to our game server, and then our game servers will actually execute the events for them. But I think it's just like a very interesting interplay between like a web app and between a multiplayer online server game. But I mean, I think it's a lot easier because there's a lot of latency concerns, and like it's kind of like the logic is like a player executing a script, it should have the same amount of latency as the player like pressing 1 in their keyboard. They shouldn't have to go through like the whole internet for both the script and them pressing like a button in their keyboard should have like the same amount of like power essentially, and the server should be able to acknowledge both at the same time.
So you want to be able to run the code while also being able to play the game at the same time.
Yeah.
Oh, okay.
But the part of the reason why like I was thinking a little bit of like players can write scripts on the website and then press enter and then they can see, like that's just really cool. Like you can write scripts in a website like send the events to the game server, and then the game server is actually going to respond accordingly, and then they could see that inside the game while they're playing. And then you can you have access to everybody's code basically, and you have data around how frequently they're using the code, and you have logging and all that fun stuff. So that's very interesting. And I've never heard of any game having that, but maybe it's not fun. I don't know.
A login? I'm sorry.
Basically, if you make everybody write the scripts online, you're able to capture every single data point, their scripts and how long they spend and everything.
Right.
Just think about it, what if your leak code, everyone writes leak code on leakcode.com, right? And then leakcode.com runs your code too. What if the code you were writing was sending messages and controlling your character in the game?
At the same time.
So that's all it's doing, right? It's you're not running leak code. You're going to Edwin's MMO.com or Edwin's MMO coding site.com, and you can run your script, and then you can watch your character that's sort of executing the script that you put on, a leak code interface. Right, Edwin?
Yeah.
Well, I'm trying to.
Yeah, I so.
Yeah.
Won't be the only problem with that I don't. So it's not local at that point, right? You're essentially you don't get to use your own computational power to control the character, but a little bit of computational power running some Python functions is not that expensive anyway.
Right.
And then you have the extra business model, Edwin, of having everyone's data the same way Leak Code does, of who's good at writing video game code.
Yeah, and then you can have ads and all this shit.
But no, you wouldn't want ads within a video game, right?
Yeah.
But that's the way to make shitty video games.
Yeah. Well, all these mobile games have ads and Candy Crush, and they seem to be killing.
Yeah, those are the worst.
No, but it's just very interesting to me. But I do think there's a latency concern, and I think having the player writing the scripts in the client side is a lot cleaner, and it's been done before, and it seems like it's less cheating in a way because it's more intuitive because you're writing a script, but then you can also play the game at the same time simultaneously, and you can see the script, executing your character. It seems like it's coming from you as the client, whereas if you're writing scripts in a website and you're sending events to the server, there may be a latency period, and then also it's kind of there's kind of a divorced feeling because now your clients you're playing the game at the same time, of course, but it's not really using your own computational power. But there is an interesting point, and the reason why I kind of like the root code REPL idea is because not only do you have access to all the data, but it's very accessible to everybody, to noobs and everybody. Because all you have to do is just go to our website, and then you can execute your own little scripts. You don't have to set up you don't have to put your files in this certain folder directory or do any of this stuff.
Well, that's just because MacRequest was made shittily. That wouldn't be necessary for any system.
But we still have to designate an area where players can save their scripts, right?
Oh yeah. Good point. My bad.
Yeah.
I would do it. You were thinking about doing it in a repo, and I think the other thing that I think you're hitting on that I think is absolutely right is thinking of things as events, because that's the best way to combine what users can do with your game as well as what programs can do. They can each create events, right? So if I click the fire button, I can create an event that is a fire, or if I'm interacting through the app or through my script can create these events, and that's how I automate it. And there's definitely going to be some computational overhead or whatever network traffic, but definitely for getting it started, I think that's an absolutely great way to be thinking about it.
Yeah, because it's once we build the fire event, then it doesn't matter whether the player is clicking on the keyboard or whether they're executing like the fire event in code in Python or whatever, because both should be executing the same event code of like firing.
Wait, Edwin, one of the things you mentioned is you thought there would be a like slower latency if you do the leak code style approach. I don't think it should be slower if it needs to be tightly coupled with the actual server, right? And it could actually be way faster than running stuff locally, because if it's tightly coupled with the actual server that runs the game stage, then it can access your variables faster, and it can send commands faster. So what do you mean about it being slower? Like, it's not going to go to your computer and then go to the server. It's just going to directly message the server, right?
Like, not necessarily slower, but what I meant was that basically, like, for example, let's say you're correct, right? And running it on leak code is going to be a lot faster than doing it in your client computer, right? So that puts everybody who's just playing the game with their keyboard at an immediate disadvantage, right? So everybody's just going to play using the website. Whereas
they don't have a click user interface.
Yeah. Whereas if you were executing your scripts on the client side, or just pressing up down and your left mouse button in the client side, you're using. Of course, the code is likely going to be a lot more responsive and faster than you pressing the up or down arrow, but at least you're put on the same. At least everybody's on the same footing, that they're only limited by their own network traffic, right? Whereas now, if we make this website, it's going to be like a two-tiered system. People playing using the website latency versus their own client side. Does that make sense?
I don't know if gamers care about that distinction, right? Like, when people talk about fairness in games, they're not, it should be like removing the power of your computer entirely, not just focusing on like you not losing latency due to these
I plan to cover in future videos, including.
Yeah, I mean, to be fair, I do like, because obviously we know how to build web applications from scratch, so it's not something that's it's very interesting. Like, if we are able to build a web app that sends events to our game server and allows everybody to just write their scripts online and executes them, and then they can see it happen in their game. That's really cool. Or we can go the embedding the Python or Lua scripting virtual machine, or do both. I don't know. But yeah, those are just the ideas that we're shooting around with.
Oh, this is very exciting.
So that's the scripting part of the game. Which I think is the real innovation of the game, is allowing players to write code to execute events. So everything else, the multiplayer, I've already demoed how the multiplayer would be built up. It really has to be done from the inception of the game. Otherwise, it's very painful to integrate multiplayer for an existing single-player code base. But you really have to think about the variables you want to replicate, that you want the server to send to the client side from the very beginning of how the code base is built. Otherwise, you're going to have a lot of headaches down the road once you decide to put in, once you want to make the game multiplayer. And the rendering itself is, it's very interesting stuff. If any of you are interested in 3D graphics rendering and world building and doing the levels, it's something that I've been reading up on. And when you're using Unreal and you're building up the level, let's say you're building up this particular level, it's there's a lot of I guess it's you're not really doing anything heavily mathematical. if you're using pre-existing assets, it's just a lot of like, for example, you're just like modifying the landscape and doing all the sculpting. But it's very interesting stuff. And I wouldn't mind us delving more into the actual rendering and graphics part of the game itself. But yeah, like I think we also want to get the basic gameplays going on, and then the levels we'll worry about them as they progress.
This has been an awesome presentation. Thank you, Edwin.
Yep.
So we were supposed to have Evan and Joe as well talk about a serverless framework, but Evan and I have been messaging. And since that conversation was kind of going super well, I thought we might as well keep the conversation going and postpone the talk about serverless. So that was kind of a decision I made on the fly. We do have like another 17 minutes if anyone has something to talk about or comfortable for taking suggestions. Evan, would you want to do a quick demo, or do you think 15 minutes would be enough?
I mean, yeah, we could run through it real quick. Would everyone want to do that? I would just ask. Bear with me. I'm working on an ultra wide monitor. If I try to share my screen and whatnot, just let me know if it looks real bad. We could at least get through maybe the Hello World application real quick.
Awesome.
All right, let me see. Give me 1 sec. Alright, can you guys see my PowerPoint alright? So
yep.
I think if I try to present this full screen, it will mess things up. So I'm just going to kind of walk through real quick. So I shouted out in the text channel earlier, if you want to kind of do this on your own, I really the basic place to start is to just create an AWS account, get set up with a credentials file, so that you just kind of have it in your root directory. A lot of things, like a lot of Python packages, Boto 3 namely, will just automatically look for your credentials there. And it just makes all of this go so much more smoothly if you have this set up ahead of time. So I'm more familiar with this tool that we're talking about today, which is called Zappa, and I wasn't as familiar with why go serverless versus something else. I think for your personal project and as a developer, you should just kind of be aware that there are different ways to host things now. You don't need to have a server that's running kind of 24/7. You can use these so-called serverless applications that kind of wake up and warm up when they receive a call. A tool like Zappa will actually keep the serverless application warm, per se, in that it will make a routine call to it so that someone's not waiting 4 minutes for AWS to allocate a machine to your serverless application on the fly. But I shamelessly pulled this directly from AWS's serverless page as some of the pros for going with this. I'm not, an AWS architect. I'm not here to sell you on serverless applications. I'm here to just as maybe a tech evangelist to let you know that there's this extra piece of this great Python library out there that you can make use of for your personal project or probably at work or something. So what is this going to be? It's my favorite thing. It's a Flask app. So all we're really going to do is deploy a Hello World application using a tool called Zappa. And so let's just take a real quick look at the Zappa page on GitHub. So what is it? Serverless Python. What's so great about it? It has a ton of features, more than you could ever possibly need. And you can get it set up and you can get a web page running in just literally under 3 minutes. It's pretty awesome. All you got to do is install it, you initialize your first project, and you run deploy. and you'll have a serverless application. And assuming you follow this kind of tutorial, which like, look, here in this GIF, they're doing kind of something similar. You can have kind of a web app up and running very quickly. So to just finish out this presentation, or the PowerPoint part of this, we're basically just going to initialize after setting up a virtual environment. We're going to run a deployment, and then if we make any changes, there's a separate command to just update. I also shamelessly stole this from the README on Zappa, but there's a lot of fancy stuff going on under the hood, a lot of automation, which is something we all love. So if you're interested, I shared this PowerPoint in the text channel. So feel free to kind of get set up on your own and to really dig into kind of the architecture in your own time. Or if we have time to ask about questions, we can delve into that as well. So what I'm just gonna do now is change over to VS Code real quick.
Midnight.
And now you can see my VS Code, all right?
No, it's just like I have something
It's the
similar.
default, no?
Huh?
Isn't this the default?
No, not midnight.
Oh no, I guess I set this up a while ago and I forgot.
Probably, yeah.
But hey, so I have like a really bare bones Flask application here, right? I'm in a directory called Zappa CG Live for Coding Guild. I have an actual folder, which is Zappa CG Live, that's going to contain my Flask app. I have the actual app.py, just really simple. All we're going to do is return hello world on a page. But I wanted to kind of walk through these steps with you guys. So I also have a virtual environment here, which is pretty important for Zappa.
Shout out to Andre.
What's up?
I said shout out to Andre.
Oh yeah, shout out to Andre, exactly. It's funny, the example project I have for this on my own GitHub uses pipenv, and Andre helped turn me on to the fact that it's not supported anymore, so thank you for that, Andre.
I think they just pushed like 1 million commits to master, or rather from master to a release. But
Wow.
it was it was something ridiculous, like 1,700 commits behind master.
Yikes, man. That sounds like a nightmare.
Yeah.
If you're not familiar with setting up this virtual env, or you forgot about Andre's presentation, all I really did was Python. In my case, I'm using like Windows subsystem, so I have to use Python 3.7. I just did venv. What that will do is give me a little folder up here, which is my virtual environment. So then I'm just going to activate that. You also should make sure you just pip install Zappa and Flask. I'll do it right now. I do have them installed already, though. At least I think I have them installed already. Oh yeah, might not.
Yeah,
Nice.
nope.
So I saved it for the live. We'll do it live. So yeah, I guess while this is kind of just building and installing dependencies, if you have any little questions so far, I'd be glad to field them, or at least try. Definitely not a serverless application architect.
So what I find interesting about in the myapp file is that if you can call the file directly from your local computer, and it'll call this app.run, which is how Flask runs apps. But I imagine that since as a serverless function, it actually doesn't call that file. I imagine what it's doing is it's just finding that there's an index function, and it calls the index function when you call the route.
Yeah, it's kind of like that. What you'll actually see is that we reference directly this app object when we run Zappa init. All right, cool. So now we're here. So yeah. So I'll do that right now, and we'll walk through the steps. So we are going to start with Zappa init, which is kind of just like the entry point for setting up a Zappa application. and basically it does something that I love. It just like literally walks you through setting up. It doesn't really expect you to know how to do really anything yet. It assumes you're stupid, which is just really great. So I'm not going to change any of the default settings. We're going to go with dev. I am going to change the name of the bucket though.
Zappa.
So this is like getting into like AWS and if you're on the free tier and stuff, this isn't going to end up charging you any money, but it will create a bucket, so you should be aware of that if you want to delete it at some point in time. But it's going to name it whatever you decide. And so you can see here something really awesome, which is that Zappa just automatically discovers my Flask application. Like I literally didn't even need to tell it where it was. It knows that it's in this directory of Zappa CG Live, my app, and then it references this variable, which is pretty interesting, which is an object. So it already knows where it is, so I can leave that as a default. This part is like, no, this is a personal project. I don't want to deploy it globally, so I'm probably going to limit it to one zone in AWS. So now what we've spit out is this. Sorry, I'm getting a notification. Close this. Now what we've spit out is this Zappa settings.json file, which is just exactly what it sounds like. It's just a configuration for our app. So you can actually have separate like dev and prod environments wrapped up in this configuration, which is really cool. Right now we just have a kind of a dev portion of it. But if you were testing and if you were running in production, it's a really great way to separate those logically. So now it's just asking if this looks okay. Yeah, totally looking okay. So now we're just going to go ahead and deploy this. Zappa deploy dev.
Yeah.
Let's do it.
Awesome.
And of course, like this is an extremely bare bones application. I'll share a link on my GitHub. I have one that takes kind of the Zappa sample application, which ingests a photo and converts it into a thumbnail for you. That is a little more involved on the Flask side, so that portion of it is not as beneficial, I think, as just like creating a Hello World application with Zappa in the first place. But I can share a link to that if you're interested in just having a jumping off point for that kind of thing as well. So what Zappa is doing right now is kind of, you can actually see it creating them on the side here. It's packaging up things into a zip, into a compressed file, because that's kind of how AWS expects it to be. So it's kind of shipping this off to AWS and deploying your application. And now if I am to go to this web page, let me just switch my screen. Right. Now I have a simple application that says Hello World. It's literally anyone in this chat can go to this ridiculous URL and see Hello World right now.
Paste it in chat.
I will paste it in chat. I'm willing to pay the $1 for the week for you guys to all hit this website.
All right, DDoS, take it down.
I actually wonder how much load it could handle, but yeah.
Will
So-
it yell enough to deplete your bank account is the question.
Yeah. So you got to be careful with AWS, but
Yeah, that's true. You gotta be careful.
occasionally they send me alerts though, so I usually don't get charged, which is nice. But
Yeah, I got alerts all the time. Like,
you do?
Yeah.
Jeez, man.
I don't know why. I don't barely use that.
So I guess I'll show you really quick on my GitHub. I've kind of gone through this as well. Here it uses pipenv, as I mentioned earlier. And the actual Zappa example is a little more in depth, where we have like a template for uploading files. And this is kind of the standard Zappa example if you want to get this up and running on your own. Another like thing I'll just plug here really quick is, since the deployment for this is so easy, it's such a great like extra thing to be able to talk about at like interviews or even in like a phone screen or something, that you have a basic application set up with some kind of continuous integration and some kind of continuous deployment. And you can do that really easily and basically for free, literally, with Circle CI. And all you need is like a configuration file like this. And so if you check out this config file really quick, basically down here, I'm just running, Zappa update. And if that doesn't work, I just run Zappa deploy.
Can you repeat? I'm sorry.
Yeah, absolutely. So this is a file for Circle CI. And so Circle CI is a continuous integration, continuous deployment tool. And so since we just learned how to deploy something with Zappa like extremely easily, it should be really easy to integrate those steps into a continuous integration pipeline. And that's exactly what this Circle CI file is doing here, this config file. And I would encourage you to shamelessly steal this file or to go to Circle CI and try it yourself and to test it out with Zappa, because it's a really great way to have kind of an easy thing to talk about with setting up CI/CD, which is part of just every developer in the world's workflow. It's important at every company, and it's a great thing to be able to talk about. So I just want to leave you with that tidbit because I do think it's a little bit important. And I also leave a note here about setting up your environment variables in Circle CI. Right. Basically, you can set your AWS credentials as environment variables, just like we set them in our AWS config on our local machine. And that will allow you to seamlessly run these deploy functions. So it's kind of just a really nice way to wrap up this whole thing as like a small personal project, and to be able to share it with the world. So now anytime I actually push something to this repository, it automatically updates my example site, which is just really nice, powerful automation to have.
Automation. Wait a second.
But yeah, that's kind of it for me, guys. I know we're like just about at 9, so I'm glad I got to squeeze that in. But if we have any quick questions about this, we can talk about it really quick. Anything importance of like small personal projects, I'm like definitely a big fan of those, and I've been trying to do more small things instead of one big thing as of late. So I'm into that kind of workflow lately. If anyone's, whether for better or worse, I just like exploring new things.
So do we.
Yeah.
Hey, senior people, Andre, Matt, Lee, why don't you guys start?
My thing would be this seems like a fantastic tool for just getting started with deployments. And I know during the coding bootcamp we went through Heroku, which has a little bit more of an overhead. Still not a lot. It's still like meant to be like a lightweight service. But honestly, this seems like a fantastic tool for getting people to learn how to deploy a Flask app real quickly. So awesome, very cool.
Yeah, and thank you, Edwin, because of Edwin, I know how to deploy Heroku. He was so pissed at me. He's like, "How come you don't know how to deploy Heroku?" I'm like, "I'm trying."
It's called tough luck.
Yeah, he was so mad at me. I was like, "Oh my god."
Yeah, I think this is definitely less of a headache, and I think it teaches a couple important skills like setting up your virtual environment, which is something we didn't do in the boot camp. I know I definitely didn't really do that often. And just getting comfortable with that, and interacting with AWS in some scope is really important as well.
Yeah, we actually didn't touch that subject. We did not even touch anything on that big deployment, like big data things, right?
Definitely. So, now's your opportunity, I guess. I don't
I
think
know.
this is big data, though.
No, not big data, but what was that? Oh, God, I forgot.
Would it be recommended to because there's so much hoopla over the serverless architecture, is it even worth going through Docker anymore. I just want to ask the question to the whole team: should, like, if we were to start a new application from scratch, would we not want to just make it serverless and use like something like Zappa?
I mean, so architecture is generally sort of moving in this direction, and it's like stateless architecture, and I totally think it's a fantastic way of doing things. I do think there are some subtle differences, namely if you have anything to do with state, right? Like, so we try to create endpoints that are stateless, right? That if you send a message, it doesn't matter like what past messages you sent, but if you wanted to make it stateful, that's where Zappa would actually not work.
Interesting.
Where now would work, Matt?
So if you had like a global variable that was like count the number of times that this endpoint was called, like where does the global variable get initialized? And where does it get, like, let's say this is a serverless framework, right? So the server can get taken down and up. How does that state get maintained? It doesn't. So what you have to do is you have to write to a database which is stateful, and then your serverless framework is stateless.
Oh, okay. Yeah, because right.
Like as these paradigms have kind of come up more and more, the separation of stateful application, the state in your code base from the actual code to the database. Like Zappa is now like a readily accessible thing, whereas before you really had like modern databases, you couldn't really do this.
Can you give an example of this global variable, for example? Like,
so imagine you're trying to count the number of times you've called an endpoint.
Right?
Endpoint. So yep. Right. So like now imagine that code base, right? You initialize the variable to 0, right, and then someplace else you increment it. Right?
Okay.
Well, let's say that you called this endpoint, and then 2 or 3 days later, you came back and called this endpoint again. Right? So AWS has to re-provision a new machine, and this new machine has no idea how many times this endpoint has been called.
Right.
Right? So it initializes it to 0, and that's it.
So
Andre, do you have more to add? Because I know you know a lot more than me on this.
I mean, there's a bunch of ways to do this. Like typically, if you need to do a count like this, for example, you would use something external to your app, and every time the endpoint was hit, you would increment. Like, let's say you set up like a simple counter in Redis, and then you just send an increment command to the Redis server every time that something is called, and that would be all fine because no matter how many machines you spin up or tear down, that counter will be accurate. Because each individual machine will just tell that to keep track of how many times it was called. But yeah, as Matt said, like when you go serverless, you lose control over what kind of machine is running and how that machine runs. The only guarantee you have is that there is some amount of some amount of instances of your code running at any point in time, right? That's the sort of guarantee that they're trying to provide you. Is your code is running somewhere, somehow, some number of times, but you don't get to say anything about that. So you're ceding control over the machines and how your code runs. So when you lose control like that over the hardware, and over, shall we say, the start and stop times of your applications, then it becomes very difficult to reason about like how your applications will run. Or it becomes difficult to do state, basically.
To do state?
Very control over everything in order to do state appropriately.
No, but like I think what most of people that are not, I wouldn't say senior or like mid-level, they don't understand the concept of you running that on a like what would it be a scenario of something running that, like I don't know, like Can you give an example like that? Like, I don't know, a
I'll
clock?
touch back to a comment I made earlier, which is the app.run function inside that Flask file, right? So that app.run function is actually creating a server and running it. Whereas in the serverless framework, that app.run function isn't ever going to be called, and the serverless framework is going to be responsible for everything. Right? So it really comes down to like, where do you want to meet your cloud provider? And this is meeting him as far down, right? They're deciding how many computers to provision, where to provision them, and things like that. And oftentimes, if you're like developing a POC or if you're developing it, like honestly, most apps should function somewhat similarly.
Right.
But if you want to like have a lot more control, or if you want to like, let's say something that isn't serverless, right? Kubernetes isn't serverless. Kubernetes is like you have a server and you put a bunch of little containers on that server,
Right.
right? And whereas this, like you're not defining containers, you're defining functions, right? So you're defining in that technology stack, you're defining things
okay.
that are different.
Okay.
And I honestly like, I recommend it, and seeing how simple that was to do, like that's like honestly like an awesome find for a good technology to get a simple app running, and honestly even up to like more complicated things.
Yeah, I should actually like caveat this whole thing with like, Zappa itself is, mainly used with like Django and Flask apps, so some kind of like, web server, and so you should be looking to use it for that kind of use case. That being said, the first time I encountered it was like a senior software engineer was using it to build data pipelines actually, because it has a scheduling feature with his own Django like web interface to monitor those pipelines. So probably a little like crazy, but he had done it before, probably in a ton of, it's kind of impressive. He has already done this whole thing at another company, so he had some boilerplate code to get it up and running fast, but the possibilities are endless is what I'm trying to say. Like whatever you want to do with the web app, whatever you want to do with Python is like totally up to you. I'm just trying to show you how to deploy it and do so easily.
Gotcha.
Yeah, the only thing I'd add to this is that choosing to do deployments in this way sort of shields you from a lot of potential knowledge that you can gain by doing deployments in a more traditional way, like the knowledge of hardware, knowledge of just all the things that are without going too much into it, knowledge of all the things that are done for you in serverless. So I tend to be an advocate of doing things the hard way.
No, but you're right. I think it should be done
At
like
least
that.
a couple of times. Like definitely, like I would, as you grow as an engineer, you sort of will tend to stop doing things the hard way at a certain point. Obviously, depending on what you're doing, but
No, but if you know what you're doing, that's fine, and you're just being more efficient, I would say, right?
Yeah, you're being a little bit more efficient, but it's good to know what it is that you can achieve if you don't do serverless, and what it is that you're sacrificing.
Right. But that's the biggest problem I think, Andre, with people in my category, right? Like you have a little short time that you gotta learn all these things, and you gotta like learn in a way that you know how to deploy it, but you don't know what and why is deploying it. So I think that's the biggest problem and issue with people. People know how to write a code and what that code is going to do, but they don't know exactly why. So it's I don't know. It's kind of complicated.
Yeah, I think it would be good at some point in this group to do a lesson that sort of shows the different ways to deploy something, all the way from like I'm just straight up running this process within Bash to like Docker to like serverless, and then like show the different things you have to do in order to ensure reliability at different stages, and like how things are generally abstracted from you. Because it require a bit of work to put together a presentation like that, but I think it would be useful to show.
So I mean, honestly, you senior people should give it to junior people to make those presentations for you guys, and you guys just present, as a homework. I'm all for that. I mean,
it's like junior people can make the presentation, which is correct or something.
I don't know how many people on this call would be able to. I would definitely not.
No, not you, Lee. You
Make that type of presentation. I don't think anyone junior would know about what type of trade-offs to build the presentation for.
Okay, mid-level. Let's put it that way. So it'll be a good structure. I
think part of this, the great thing about this presentation is we took something and we showed it, and like Evan did a great job of showing it, and then Andre was able to, and I were able to kind of add our little bit at the end to add more information and maybe more context about these things. And honestly, I have a lot of questions. I'd be curious how this framework would interact with Docker, because my intuition is that you would not be able to integrate Docker with Zappa, and so I wonder if anyone could answer that. I'd probably see what Harmon thinks, because he'd probably be the best person there. But
I think it's orthogonal to each other. I think serverless basically leapfrogs over the use of containers. It's very cutting edge.
Yeah. That's what I think it is. And I generally like Docker images because you have that consistency thing. But at the end of the day, if it gets people developing faster and it gets junior developers having their celebratory moment of deploying a web app, let's get there as quickly as we can and then iterate and make things more.
And also, if somebody could evaluate the cost, because I've heard conflicting statements about the cost of using Lambdas for your entire architecture, especially for very data-intensive companies and teams. So especially if there's a cost-benefit, if somebody could present on the cost evaluations of using Lambdas instead of traditional or Docker images or Docker containers.
Yeah, I think it comes down to
I mean, I can ask my old company for their bills and shit. I used to have access to all of this. I'm sure they'd oblige me, and then we splurged, I think, is the appropriate description there of what happened. But yeah, we definitely used Lambdas. We used a bunch of other stuff for data, and it was stupid expensive. So, and then that's definitely not the depth I think that you want, Edwin, in terms of that presentation. So, stupid expensive is a bit too non-descriptive. But yeah, I mean, something can be put together for that too.
Cool.
And
sure.
Just one question. Sorry, maybe I'll take you guys just a couple of steps back. Where is that serverless part? I just apologize for my ignorance. I'm just comparing this to the regular Flask app, whatever we did in the bootcamp. What is this serverless part like? We're connecting to the AWS, and if someone can just explain
break it
some
down
more.
No, to break it down for you.
So you know how with normal development you could set variables, and then when you get a function call, you can check your variables, right?
Yeah.
So with serverless, when you get a function call, you can't check any other variables. You don't have any variables until that function call. You just have your code and whatever's passed in.
Mustafa, were you confused about how similar it looked to the apps we had in class?
Sorry, come again?
Were you confused about how similar it looked like to the apps we had in class?
I'm just when the first thing came to my mind is when I read the email serverless. and it was like coded and highlighted and bolded and all of that stuff. But then I'm comparing that to what we took in class, which is a regular Flask thing. Py file, read it, function it, do whatever you want, render a template. It depends on whatever you're trying to run in that Py file. But then I'm just trying to compare.
I like what Google calls their serverless framework, and they call it cloud functions, because that in my mind is really what it is. You're essentially, instead of deploying a server, you're deploying a function, and like I really want to keep coming back to this point of that like if main statement. Evan, I'm having trouble finding your code base.
Which one? Do you need anything?
What is your username on GitHub?
Sorry, I'll share really quick. I got it right here. So what were we just looking at? Like
that my app function.
Sure.
Or my app file.
So this is just a little more complicated, but this thing.
Yeah, so what I'm saying is that function only exists in your development environment. When you're running it locally and you actually just run the file. But when you're deploying it, it doesn't matter whether or not that file is there. That app.run. So that app.run, what it does is it starts a server locally. And it connects to your your like ports on your computer, and it says, okay, on this port I'm going to be listening for messages. Oh, a message came to this port. Right? Whereas if you're going serverless, you're not responsible for that anymore. The serverless framework is responsible for taking a message from the incoming messages file and putting it into a function. Right? So you're already at the function when you have anything. And that way, like, the big thing to think about is state, right? Like when you're running a server, you have one server. When you're running serverless cloud functions, what you have is literally functions that you can call. And so you have no guarantees about one function relative to another. You honestly, I don't even think you have the guarantee that they execute in order.
Yeah, that's a fair assessment. I think just to go back to this, for like general pros and cons, I know I said I wasn't an expert, but I did take this directly from AWS. So they're trying to sell you a product. This is why they're trying to sell it to you. You don't have to manage a server. It scales pretty nicely. You pay for what you get, and it's highly available because it's AWS's servers that are being programmatically allocated. It's not your server that you're managing and can maybe move from downtime. They're basically allocating your functions to machines that they have on their end and doing so dynamically. So there's a lot of redundancy there, and they're able to scale it well for that reason.
Yeah, so we're still using AWS servers, not basically not using the local, and that's it. It's just a different naming, right? And then whatever is deployed, we have no control over that, right?
Yeah. At the end of the day, a server is still running your function because there's no other way to run it. But
with the computer involved.
Yeah. So I know serverless makes it sound like it's literally a different technology, but it's just the way AWS is allocating things.
Yeah, it's probably one of the worst names that they could have used for this. It's
true.
It's literally referring to the fact that you're not managing the hardware. That's all it's referring to.
Function. That's Google's term for it, and I think it describes it a lot better.
Yeah, Matt's right. I've used cloud functions for... another common or popular use case is like a Slack bot. You could do that as a cloud function really easily.
Slack bot.
Yep, Slack bot. Maybe we could do one of those. I'll add it to the list.
That's like whenever you type slash something in Slack.
Honestly, we have a Slack bot for the coding guild. The only thing we need to do is deploy it. So honestly,
oh, that one I created.
Yeah. Perfect. Awesome. This works 100%.
Oh,
we'll figure out how to do it offline.
Yeah, you see what the problem is? Like, you guys just talked about something that I did, right? But I had no idea I did because, So I think that's the great problem of what it's happening today. Like, a lot of people know, like, how to deploy things, like, just because they learned that way, it's so I think when you told me when people should learn like actually from the very beginning, so they have a base and understand those things, it's very valid. It's
Evan, you need to make like a bot that'll listen to like conversations and just like print out like summaries and reference material for someone who's confused.
Let's get a transcript bot that writes down this entire conversation, and then let's get an AI to summarize. Done.
Yeah, no, that would be very useful.
Oh, actually, that's a great point.
For like a Zoom algorithm or bot that just listens in, provides transcripts, and also provides automated responses, like so I can sleep during a meeting.
Oh, actually, well, Evan posted, I got fired by a bot or something.
That was a funny one.
Yeah.
Okay, let's not start with automated responses, because
I think they'll be really interested if we do that, and I can handle the Arabic language if we get it acceptable in English.
that'll be much harder to get funding for, I think.
Mo, what do you think?
She's sleeping.
No.
Mo.
Oh, man. We are very soothing.
Mo.
Mo? I checked
So,
it.
Your audio is not working, Mo.
all right.
Mo needs Edwin's version of the bot.
Mo, your audio is not. Oh, come again.
She needs it to tell us to shut up automatically so that we don't notice that she's asleep.
Mo, your audio.
Can you hear me now?
Yes.
Yay!
Yes.
Why does it always do that?
Because you're probably in the couch watching Korea
I'm
drama.
just sitting here talking to myself. My parents are probably like, what the fuck?
Oh my god.
Guys, can you hear me?
Wow. I thought you guys just hated me and were ignoring me, but no, it's just no one can hear me.
Oh my god.
You were talking during the meeting?
Yeah, oh my gosh.
What?
I hate my life.
9:30?
It's fine. I wasn't saying anything insightful anyway.
No, you're lying. I can hear the Korean guys talking in the background. Come on.
It's okay if we're in the middle of conversation. Just every time you sign on, just do a sound check.
Okay. Yeah, Edwin, you can just sleep during meetings. I sleep during all my meetings at work. Fine. You just have to half listen. It's such a skill.
Wait, what comment did you want to make, Mo?
I forgot. I'm
Oh
also
my
doing work and
god.
stuff.
Junior people,
I
don't
was
be like
actually
her.
sleeping during work today. I woke up at like 3 p.m.
Oh my god.
Hard life.
It's fine. I have to do my work now, so.
Okay.
It's good to hear your voice, Mo, as always.
Yeah, work is so easy. But then I tell my boss I don't get it to work, and I'm like, yeah, this is gonna take me a week. And then I just did it on Mondays, and I just chill. I'm like, I don't know how to write to that database. Ooh.
Oh my god, Mo.
What does he know? He's a project manager.
Oh, wow.
All right, everyone. I'm gonna hop off. Before I did, I want to thank Edwin and Evan for, I think, like 2 incredible presentations. And honestly, like this week is literally what I'm gonna refer to when I'm thinking of like why I think this is like such a powerful, like honestly, just getting together is such a powerful thing, right? Like we went through 2 great demos and then had like discussions that built off of them and touched on things. And I think, my hope is that everyone kind of was able to at least learn a little bit. And, so thank you tremendously from the bottom of my heart.
Thank you, man.
Thanks, John.
Thank you, man.
All right, have a good night.
All right, until next time.
Thank you. Bye, guys.
Bye.
Bye.
Bye, everybody.
Bye, Evan. Thanks.
All right.